Alrighty. It's been a while.
I know. Welcome back to GradMates. I'm Peter.
Caitlin.
And we have a problem that I found on a YouTube thumbnail today. So this was on a Mind Your Decisions was the channel. So thanks to him for doing a video on this. I saw this problem. I like seeing some thumbnails on YouTube and saying, oh, that looks like a neat problem. Let me see if I can do it. So today we've got this problem. I think Caitlin's going to work on it first, and then if she does it the same way that I'm planning on approaching it, then we'll just leave it at her way because she's usually pretty efficient.
Okay. I haven't done this at all. This is a new problem to me. I think the first thing I would do, since we want to solve for x, and I have this total outside thing going on, I would take the square root so I can undo this squaring. So I'm going to square root both sides.
Gotcha. Okay.
Oh.
That's okay.
Okay.
That's easy.
In my head, I was like, I'm just going to keep square rooting.
Okay.
But when you're the one doing the square root, you then get two equations.
Yeah, you get plus and minus, right?
Yeah. So I get x squared minus 1 squared minus 2.
And that whole thing's squared.
Still squared.
Minus 3.
Minus 3.
Equals.
Plus and minus 2.
Perfect.
And you know what? I think I can just leave that symbol in there.
Yeah, just leave that symbol.
Until the very end. Instead of splitting it into two
I know
different
sometimes,
ones.
if I get confused with it, I have to write it out separately, but I've gotten a little better at it not confusing me, so.
Ooh, okay. So I'll add 3 to both sides.
Yep.
So x squared minus 1 squared minus 2 squared.
Mm-hmm.
I'm going to put the 3 out front. 3.
Yeah, that's it. That's exactly what
2.
I would do.
So that way I don't think that that's plus minus 5.
Right. Okay.
And then, oh no. Okay. It'll be okay. It's fine. Take the square root. So x squared minus 1 squared minus 2. Oh my gosh. Is plus and minus the square root of 3 plus and minus 2. Holy cow. I'll add 2. This is so many. Oh my god. This is going to be so many equations to have to go through. Because I have to go through positive, 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 negative, negative. Oh my gosh. Okay. Surely there's a better way to do this.
I mean, maybe. You're doing exactly what I would do.
Okay. Holy cow.
I was just about to be stupid and say, oh, go ahead and do 3 plus 2, which is fine.
Okay. Square root again.
Yep.
So x squared minus 1 is plus and minus the square root of 2 plus and minus 3
plus and minus 2.
Add 1.
Add 1.
X squared is 1 plus Oh my gosh.
And then you got a square root.
I know. And then square root. Ooh, okay. So x is plus and minus square root 1 plus and minus square root 2 plus and minus square root 3 plus and minus 2. Now I wonder, from here, instead of having to do every possible combination,
Mm-hmm. Well,
could I rewrite those?
I wonder if you could do, instead of like trying to go through and do them all individually, just kind of go back up to the starting equation. So what degree polynomial would this be? So like if you subtracted 4 over, set one side equal to 0.
Mm-hmm.
And so that's your function that's being set equal to 0. What is the degree of the polynomial function? So you're starting out with an x squared, and then that's being squared. So that's an x to the 4th. Yeah. And then you're subtracting 2. That's just the constant part. You're squaring again, so the x to the 4th would turn into an x to the 8th, right? Or am I doing bad math?
Don't we add them?
Yeah,
No.
X to the 4th times x to the 4th, x to the 8th. Yeah, x squared times x squared.
Maybe I have been doing squared. Cubed would be 6, so you do multiply them. Okay, I don't know why I was thinking add. I was like, oh, it's going to be 6 and then 8. So then, yeah, 8 and then
again, which would be
16.
16. So are there 16 solutions that we get out of what we have? So there's a positive, positive,
Two,
positive,
two,
positive,
two.
4 across, 4, and there's actually, I guess you can say there's some other
To the fourth is
combinations because, like, you would have positive, negative, positive, negative.
Well, to me, you've got 2 options here, 2 here, 2 here, 2 here.
Mm-hmm.
So combination-wise, can't we just multiply them?
Oh, yeah.
So then 16. So there's 16 combinations.
So there should be 16 roots.
Yeah. Well, with polynomials, there should be, whether it's real or not.
Right. I mean, you'll have some real and some non-real. Because so on the inside here, 3 plus and minus 2, those are positive values. That's 5 and 1.
Mm-hmm.
So you have plus and minus plus root 5 plus root 1, which is just 1.
Yep.
So root 5 and 1. And then you have 2 plus root 5, 2 minus root 5.
Yep.
Well, that 2 minus root 5 would produce a negative, but that would be your one of your imaginary ones, right?
Yep.
So,
okay. So we still haven't even solved it yet.
Nope.
So what should we do?
Well, I guess we could start by...
Ooh, hang on. At this point... No, these are not going to be the zeros of the function, is it? Is that what, like, this is
that's
what we're...
I mean, that's what I would say.
Okay, so to me, aren't 2 of the zeros 1 and 1? 1 and negative 1?
Well, if you plug those in, it gives you a
new set.
So that would zero out, and then you would have a negative 2 squared, which is a 4, and then minus 3, which is a 1, and then you'd square again, which is a 1, which doesn't equal 4.
Yep. Okay. Okay. So we just have to do every combination.
I think so.
Okay. I'm going to write it in orange. So one of them will be the positive square root of 1 plus square root of 2 plus square root of 3 plus 2. Then we have the negative of that. Negative, whatever this is going to be. Okay, so I'm going to go back to the original, change that to a minus. And then we have the negative of that.
Mm-hmm.
Oh my gosh. Am I really going to sit here and write all 16 of them out?
No, so, I don't know, maybe we can...
I don't know.
Yeah, let's do some. So maybe we can write it out like this. But tell you what, if maybe we can just find the real solutions and say, all right, we're just going to stop with the real solutions.
Okay.
So in the first set...
Oh, just go backwards.
You had, was it plus and minus 2, right?
Mm-hmm.
So you had plus 2, minus 2. And then you added 3. So the two values... Actually, let me go back and let me copy this. Copy. All right. So I know that you'll have the inside stuff. It's going to equal plus, or say 2 and negative 2. 2
Okay.
commas. And then if you add 3, you have the same thing. And then we'll just add 3 to both of those. So that would be a 5, and then that would be a 1. Okay?
Okay, I see what
And then
you're
you
doing.
have x squared minus 1 squared minus 2. Now you're going to have plus root 5 minus root 5 positive 1 negative 1.
Oh, because you're doing... Okay.
and then add 2 to everything. So 2 plus root 5, 2 minus root 5, 2 plus 1 is 3, and then 2 minus 1 is 1. Right?
Mm-hmm.
And then square root again. So you have positive root 2 plus root 5, negative 2 plus root 5, and then you have, and there's 2 from this one, so positive 2, negative, and then positive root 3, negative root 3, and then we have 1 and negative 1. Okay, and then you add 1 to everything.
Oh gosh.
So then that would be 1 plus root 2 plus root 5, and that's x squared. And then you have 1 minus, this is a lot. So I did that one and that one, and then we have, I guess we are going to write them all out.
Right?
Yeah, I'm just going to.
Do we want the actual decimals for them or no?
So you have 1 plus, so I did add 1. So 1 to the 1 and that. Now I'm doing this one and then that one. So 1 minus. Yeah, and then you've got 1 plus root 3, 1 minus root 3, 1 plus 1 is 2, 1 minus 1 is 0. And then square root again.
Right, to do all, yeah, copy and paste it, all of those.
So you're the smart one here.
That way, you just add the square root to all of them.
Right. All right, so.
Oh, but then you need the negative of all of them too.
Mm-hmm. Now here, I'll just kind of be lazy, right? Plus and minus.
Minus. Yeah.
That looks like a 7. Ah! Struggles. I'm not used to writing like this. Plus and minus. I feel like I'm going to say that all the time. And then plus and minus 0 is just 0.
Yep. So then let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
15. Yeah, the 15.
Because it would count as 2 because you have 1 and...
Gotcha. Yep, you're right. So, yeah.
Goodness.
Wow.
Well.
Feel free to check those. Go to Desmos. Maybe see if they work. But honestly, if we're trying to find all the solutions, it's okay to have the negatives under the radicals because you get complex roots, which is fine. But if you're only interested in the negative solutions as you go, you can just say, oh, well, this 2 minus square root of 5 is negative. We'll just toss that one out. And so you can just kind of keep that in mind if you're only interested in the real solutions.
Nice.
Wow.
Well,
I hope it's right. I'm confident. Hopefully I didn't mess up writing something. But that's honestly the procedure I would do.
Yeah.
Like I said, all the plus and minuses get kind of confusing. So that's why sometimes I'll write them out like I did.
Right.
And it's easy to keep track of them when you do.
Gosh. Crazy.
Right. All right, we'll have to do another one.
Right.
Classes are going to be starting before we know it, right?
Yeah.
So we can kind of get back on a more routine schedule when that time comes.
Right. I hope we can get some more submissions in.
Yeah. Submit your problems. Maybe we can solve them, hopefully. I mean, we've got a piece of paper that says we can. So, thanks for watching.
See you next time.